Hello Year 9 and welcome to exercise 8D, factorising the difference of two squares. Now, straight away we're going to start off by talking about what a difference of two squares are. So, let's first of all focus on what the word difference means. Difference in maths actually means a minus sign. We have multiplication is the product. Addition is when you add, subtraction or difference is when you minus, quotient is when you divide. So we've got a classic case here of looking for a minus sign. Now the other thing that we need to concentrate on is this. We've got two squares, so we've got to look for a minus sign, and it has to be between two different terms that are both perfect squares. So let's have a look at our 6 different questions here and decide which ones of them might be difference of two squares. Let's look at the first one on the top left here. There's a minus sign, difference. There are two terms, 2. So we've got our difference of 2. We've just got to check if they're squares. The A has a squared above it. The B has a squared above it. They are perfect squares. The reason they're perfect squares is because A times A gives A squared and B times B gives B squared. So, the first one, yes, it is a difference of two squares. Let's look at the next one. I've got two squares. I've got two terms. They're both squared, so they're two squares, but this is not a difference because it's a plus sign. So, that is not a difference of two squares. Let's go to the next term. I've got a difference sign. I've got two terms. Are they both squares? The A has a squared above it. The B does not. So it's not a difference of two squares. They both have to be squares. So that's not a difference of two squares. Let's go to our next term. It's definitely a difference, and there's two terms, but neither of them have squared, so no, it's not a difference of two squares. Let's look at our next case. Difference, because there's a minus sign, two terms, and they're both squared, a difference of two squares. Now, the last one is a trick one. Let's have a look at it. A difference, yes. Two terms, yes. Both squares. Well, the answer is actually yes, because A times A gives A squared, and we can see the squared sign there. What about the number 4, though? Well, what we need to remember is this. 4 is a perfect square because 2 squared is equal to 4. Remember when we were dealing with surds? We had certain numbers. 1 times 1 gives 1. 2 times 2 gives 4. 3 times 3 gives 9. 4 times 4 gives 16. 5 times 5, 25, and so on. They are called perfect squares. And if one of those numbers is a number in the question, then it's a perfect square because in this case the number 4 is actually the same as 2 squared. So, A squared take 4, yes, it is a difference of two squares. A little bit trickier there. Now, what I want to do is consider A plus B, A minus B. Now that's a set of brackets, and let's multiply the brackets out. So, here's our technique. It's the FOIL method, or expanding the brackets. First of all, A times A gives A squared. Now we're going to times the A and the B, but there's a minus in front of the B, so A times minus B gives minus AB. Now we multiply the inside terms. B times A, and they're both positive terms, gives plus BA, which can be written as plus AB. Doesn't matter if it's BA or AB, they're the same letters. And the two last terms are positive B, so we're timesing a positive B to the negative B, and they multiply to give negative B squared. Now what we need to notice is this. A minus AB and a plus AB, when we add them together, will actually cancel each other out. You'll have no ABs. And so if you have no ABs, they're gone. And so the answer is just A squared take B squared. Let's have a look at this answer. this answer is a difference of two squares. There's a difference sign, there's two terms, and they're both squared. So a difference of two squares actually can be factorized into two brackets. Now notice, when we look at the two brackets, they both start with the letter A. They both finish with the letter B. And one bracket has a plus and one has a minus. And it doesn't matter whether the first bracket was minus and the second bracket was plus, or vice versa. So I could have also had it like this. A minus B, A plus B. That could have also been the way it factorized. So let's try doing some questions. Oops, went too fast there. Right, let's have a look at our first one. A difference of two squares. Is it a difference of two squares? Yes, it is. There's a minus sign. Two terms. That's squared. Is that a perfect square? Yes, it is, because 4 times 4 gives 16. 4 squared is 16. So that can be written as two sets of brackets. Each bracket begins with the letter A. Each bracket ends with the number 4, because 4 times 4 is 16, and one bracket gets a plus and one bracket gets a minus. Let's try it again. Do we have a difference of two squares? Well, there's my difference, there's my minus sign, there's two terms. Are they both squared? Well, there's a squared there. Oh, is 144 a perfect square? Yes, it is, because 12 times 12 is 144. And because 12 times 12 is 144, this is a difference of two squares which will factorize. Each bracket will begin with the letter M and end with the number 12, because 12 times 12 is 144. Looking at the M times M gives M squared. So each bracket starts with M, finishes with 12. One bracket has a plus, one bracket has a minus. Again, it doesn't matter. I could have put the minus first and the plus second. It wouldn't matter, as long as one bracket has a plus and one bracket has a minus. Righto, let's look at part C of example 1. Is it a difference of perfect squares? Well, it's a difference. Yes, difference, because there's a minus sign. There are two terms. Are they both squared? Well, 36 is a perfect square. 6 times 6. X has a squared above it. Yes, it's a difference of two squares, but notice the number comes first. So this will factorize into two brackets, and each bracket will begin with a 6 and finish with an X. So we get 6 plus X, 6 minus X. And just so we can, I should have done this earlier, just so we can see it work, let's times this out. What's 6 times 6? 36. What's 6 times minus X? Minus 6X. What's X times 6? Plus 6X. And what's X times minus X? Minus X squared. And when you look at it, a minus 6X and a plus 6X cancel each other out, which means we end up with we end up with 36 minus X squared. And that is what we began with. So that's just expanding the brackets out to check that we got the correct answer. When we factorize, it means put it into bracketed form. When you expand, it means get it out of bracketed form. So we're factorizing this question, so we're putting everything into bracket form. Let's try part D. 25e squared, take 1. Let's check. Is it a difference of two squares? Well, it's a difference because there's a minus sign. There are two terms. Are they squares? Let's think about this. The e has a squared above it. Is 25 a perfect square? Yes, because 5 times 5 is 25. And if I think about it, 5e times 5e equals 5 5s are 25 e squared. So 25e squared is a perfect square because 5e times 5e gives 25e squared. 1 times 1 gives 1, so 1 is a perfect square. So two brackets. Each bracket begins with 5e e, because 5e times 5e gives 25e squared, and each bracket ends with a 1. One bracket gets a plus, one bracket gets a minus. Try doing part E by yourself. Does it make sense? Let's check first. Is it a difference of two squares? Well, there's a difference, minus sign. There are two terms. Let's look at the first term. Is that a perfect square? Well, 3 times 3 gives 9, and k times k gives k squared. So 3k times 3k gives 9k squared. 4 times 4 gives 16. Yes, it's a difference of two squares, because each term we can actually think of as perfect squares. 3k goes at the beginning of each bracket. 4 4s are 16. So 4 goes at the end of each bracket. One bracket has a plus, one bracket has a minus. Now, let's look at part F. Is it a difference of two squares? Difference sign. Well, the A and the B have squareds above them. 49 is 7 times 7. 64 is 8 times 8. Yes, it's a difference of two squares. There'll be two brackets. One bracket will have a plus, one bracket will have a minus. Each bracket will begin with 7a, because 7a times 7a is 49a squared. Each bracket will end with 8b, because 8 8s are 64, and b times b is b squared. So there's your answer. Now we're going to get tricky. This is quite an interesting question. Is it a difference of two squares? Well, the answer is yes. There's your minus sign. If we look at the last term first, 16, is that a perfect square? Yes, because 4 times 4 is 16. What about the first term? Well, the answer is yes, because the bracket has a squared above it. If you actually think about it, a plus 3 times a plus 3 equals a plus 3 in brackets squared, because it happens twice. So it is a perfect square. So each bracket is going to begin with a plus 3. Each bracket is going to end with 4 4s are 16. One bracket will have a plus, one will have a minus, but because this came inside brackets, when I write the solution, notice I've used brackets inside brackets. Now what I did do was I started by putting a square bracket. You don't have to use square brackets. The beginning of each bracket was the a plus 3. I kept it in brackets because it was in brackets in the question, and each bracket finishes with a 4 because 4 times 4 is 16. This is where things get interesting. If you look inside the first bracket, it's actually got a 1 in front of it, and 1 times a, 1a, 1 times 3, 3. I can just ignore those bracket signs. They make no difference to the question. So realistically, this is actually just a bracket that says a plus 3 plus 4. And the second bracket says a plus 3 take 4. Now what's 3 and 4? 7. What's 3 take 4? Minus 1. So let's see how we can write this answer. A plus 7 and a take 1, because the 3 plus 4 give the 7, and the plus 3 take 4 gives minus 1. A much trickier question. Now, part H is by far the hardest question here. Let's check why. Is it a difference of two squares? Well, minus sign, so it's a difference. Two terms, so a difference of two squares. Now, is 3 a perfect square? Let's just go back over what our perfect squares are. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5, 6 times 6, 7 times 7, and so on. When I look at it, 3 is not mentioned up here. 3 is not a perfect square. When I look at the 48, 48 is not a perfect square. Neither of those numbers are perfect squares, which means that's not a difference of 2 squares question that we can solve. Certainly not easily. But there's something else that we need to do with this question. And we should have done with all of the earlier questions, but we didn't need to, and I'll talk about that more when I get back. Have a look at the question. 3 is in the first term, 48 is in the second term, 3 goes into 3 and 3 goes into 48. Each term has a common factor of 3. So let's take out the common factor. Now 3 goes into itself once and 3 goes into 48. How many times? 16. So let's just double check that. 3 times m squared gives 3m squared, and 3 times a minus 16 gives minus 48. So I've factorized that question. Now I want to focus just inside the factorized part of the bracket. M squared take 16 is a difference of 2 squares. Forget the 3 out the front. There's my difference. There's 2 terms inside the bracket. M has a squared. 16 is 4 squared. It's 4 times 4. So I can actually write equals 3, and then in my 2 brackets for factorizing m squared take 16, each bracket begins with an m, each bracket ends with a 4, one bracket has a plus, one bracket has a minus, doesn't matter about the order. Notice a 3 out the front because of that common factor. Finished. So that's factorized the hardest one there. Time for you now to try some of these questions. Do as many as you can, do as best you can, and if there are questions you're stuck with, highlight them, mark them so that when I get back, I can actually go straight to them for you. Have fun.